today lecture 9 we have discussed about 12 properties of mechanical properties. Okay, so we will again revise them. So पहले 4 properties थे. First and foremost was strength. So strength is a property which resists the force. Okay, strength is a property which resists the force which is acting on a body. Okay, second one is stiffness. So stiffness resists what it resists? It resists the deformation. Okay, stiffness resists deformation which is produced. Then third one is toughness. Toughness does what? Toughness is resisting fracture. Then fourth one was resilience. So it is resisting what? Shock. It resists what? It resists shock. So then we came across elasticity and plasticity. So elasticity is a property in which material will regain its shape after the load is taken, and plasticity means it will not regain its shape even after the load is taken. For example, coin forging is done in plastic materials. The seventh one is ductility. Ductility is the ability of a material to convert itself into wire. So it can withstand more tensile force. Okay. So ductility is maximum of mild steel. Then it will be of copper, then aluminium, then nickel, zinc, then tin, and then lead. So ductility of lead will be minimum and mild steel will be maximum. Okay. Eighth one is malleability. So malleability is also a property of a material, okay, to convert itself into roll by hammering thin sheets. Okay, ductility which permits roll into thin sheets. So the order of malleable material is lead is maximum malleable, then soft steel, then wrought iron, then copper, then aluminium. Okay, so lead, soft steel, wrought iron, copper and aluminium. Ninth one is brittleness. So brittleness and ductility are opposite to each other. Okay, in ductility what we see that it can withstand wire-like structure, but in brittleness it is opposite to ductility and it will break down if we apply any type of force. Cast iron is a brittle iron. Okay, next comes creep fatigue. 10th one is creep. Creep means when we increase the temperature of an object, of a material, okay, after a long time it slowly changes deformation. Okay, it slowly changes its position. So that is known as creep. Then fatigue. When continuously we hit any object, continuously when hammer any object, it will break before its yield point. Okay, it will break. So this is known as fatigue. Okay, so we have to the failure is caused by means of progressive cracks which is found, and last one is hardness. 12th one is hardness. So hardness is very important property. Okay, so it means that resistance of wear. Okay, resistance. So you can remember with this 4 only. Hardness comes as resistance of wear and tear, then scratch, deformation and machinability. It also means the ability of metal to cut another metal. So hardness cutting tool. We use cutting tools which have good hardness, right? So this much was 8 for this thing. Now we will move to the first and foremost topic, that is pig iron. So what is pig iron? Pig iron is a crude form of iron, pure iron. How pig iron is made, that we will study. Okay. So first of all, before studying about pig iron, we need to know that pig iron is obtained from smelting of ore. So iron ore is smelted or melted, and then you get pig iron. So you should be knowing about iron ore. So there are 3 types of iron ore. One is oxide, another one is carbonate, and third one is sulfides. Okay, so in oxides we have magnetite, that is Fe3O4. Then we have hematite, Fe2O3, and then we have laminate, Fe2O3H2O. Okay, these are oxides, oxide ore. Then carbonates, we have siderite, FeCO3, and sulfate we have pyrite, FeS2. So these are the 3 ores of iron which we have to remember. So magnetite is iron ore, hematite is iron ore, lamatite is iron ore. So these things you need to keep in your mind. Then carbonite, FeCO3, pyrite, FeS2. Okay. So now moving to the third topic, that what percentage of a substance contains what? Magnetite, for example, is black in color. So magnetite is what? Which color? Black. Okay. Then hematite is red. It is red, so I will write with red. Then limonite is brown, so I don't have brown, so brown. This also brown. Okay. Now iron content is maximum in magnetite 72%, in hematite 70%, limonite 60%, then in siderite 48%. We don't use sulfide because it contains less than 35% of iron. Okay, the sulfides we don't use much. Okay, so pig iron is obtained from iron ore in 2 steps. Iron ore, this iron ore is converted into pig iron. How? First we will undergo the process of concentration. Okay, ores are concentrated, then they are roasted. To remove moisture we have to roast or calcinate. Once they are calcinated, so that moisture, carbon dioxide, sulfur, arsenic, all this goes. Then we do smelting. Third process is smelting or melting, whatever you consider, in blast iron. Okay, So in blast iron we have to smelt. Now we will know about blast iron. So what is blast iron? So blast irons are a chimney-like structure which have heavy steels. So there are the boundary of heavy steel plates like this. Okay, and it is around how many meters? 1.2, and there are fire bricks also. Okay, bricks. So this thickness is 1.2 meter to 1.5 meter. The thickness is 1.2 meter to 1.5. It is also 30 meter high with maximum. So height is how much? 30 meter. And maximum diameter is 9 meter. 9 meter is the maximum diameter of the cross section. The portion of furnace above its widest cross section is called stack. So this is known as stack. The topmost portion of the stack is known as throat. So this is known as throat, the topmost portion through which the charge is fed into the furnace. So from here we will get the charge. Charge means iron ore, okay, which is going to be smelted. The portion of the furnace below the widest cross section is called bosch. So this is known as bosch or burning zone. The bosch is provided with holes of number of water jets, iron blowing pipes known as skewers. So here they provide with this type of lines from where the heat is introduced inside the burners. Okay, there are 12 to 15 number of tutors. Okay, so in the lower part of the furnace, that is zone of fusion, you can see temperature range between 1200 to 1300. Okay, in middle portion, zone of absorption, this is middle portion, zone of absorption, you will see temperature range of 800 to 1000 degrees Celsius. And the above upper zone, which is reduction zone of reduction, here you will see the temperature range of 400 to 700. Okay, now at the bottom of the first furnace, molten iron is sink. So molten iron which is melted will be sinking here at this bottom, and above this there will be a slag which is of some slags will be there which will be protecting the molten iron from getting oxidized. This molten iron is known as pig iron. What it is known as? Pig iron or pure iron. Okay, pig iron. The slag from the blast iron consists of calcium, aluminium and ferrous silicate. Okay, ferrous silicate. It is used after we take this slag is used in road building, okay, railroads, etc. So this is how the working of this blast iron is. Now the pig iron which we get from the blast iron is 90 to 92% iron. Okay, it is 90 to 92% iron. Okay, and very less amount of carbon, silicon, magnesium and phosphorus is present. So now in iron, carbon plays a very important role. Okay, so in pig iron, carbon can be in two forms, either free form or in bond form. So the free form is known as graphite. It is known as graphite, and when carbon is making bond with iron, it is known as cementite. Cementite or perlite. Okay, so two types of this thing, iron carbon bond, okay, free and bonded. So free graphite and other one is perlite. So freely carbon will make the material coarse and soft, okay, and cementite will make the material more like, it will make the material fine, okay, fine core grain, and it will be hard, okay.